Hey everyone, welcome back to the channel. Today we're thrilled to unveil version 1.50 of AutoCodeAgent. In this release, we're introducing three cutting-edge RAG techniques as powerful new tools to supercharge your data extraction, analysis, and synthesis workflows. Tailors have expanded our arsenal with three innovative RAG techniques: Llama Index Context Window RAG. This tool takes document retrieval to the next level by dynamically enriching each text chunk with adjacent sentences. With a configurable window of neighboring context, it ensures that your retrieval outputs are both highly relevant and contextually complete. Whether you're retrieving market trends, research insights, or legal documents, this technique stitches together a fuller narrative, overcoming the limitations of isolated text fragments. Hypothetical document embedding, HyDE. This approach expands short queries into detailed hypothetical documents. Leveraging advanced language models, it generates an enriched query that aligns more closely with stored document embeddings, effectively bridging the gap between concise inputs and complex documents for more accurate, context-aware search results. Adaptive Retrieval Augmented Generation (RAG). An adaptive RAG system tailors document retrieval to the query type. By classifying queries as factual, analytical, opinion, or contextual, it dynamically refines its search strategy using targeted LLM prompts. This approach delivers precise, context-rich responses by selecting the most relevant documents based on the query's nuances. Download the repository, the link is in the description, run it with Docker following the instructions in the readme.md file, and test its functionality. If you like it, leave a star and contribute with a fork. Pull request, issue, or feedback. And if you are a programmer, come on, let's collaborate together to make an innovative project grow. Don't stop watching, because in the next section, we'll dive deep into the Llama Index Context Window RAG. We'll break down its fundamental concept, walk you through a live demo using it, and explain the code in detail. Plus, check out the description for 2 additional videos where we explore hypothetical document embedding, HyDE, and adaptive retrieval augmented generation RAG. Stay tuned for a comprehensive look at these cutting-edge techniques. This technique is based on the concept of context enrichment window to improve document retrieval from a vector index, Llama Index, with the goal of enriching text segments, or nodes, with additional context so as to avoid returning isolated text fragments. The tutorial is divided into two main parts: corpus ingestion and document retrieval, where corpus ingestion involves loading documents, splitting them into chunks, and enriching the context with a window of adjacent sentences, while document retrieval focuses on querying the vector index with a custom post processor that reconstructs the original context around the target sentence. In Part 1, ingest corpus.py, the function Llama Index.Context Window ingest corpus is responsible for loading documents from a specified directory, applying a transformation to enrich each chunk with a context window, defined by the number of adjacent sentences, checking whether an index already exists on disk. If so, new nodes are added, otherwise a new index is created, and persisting the updated index. The code first reads environment variables such as LAMA, index context window D, B path, the path where the index is saved, Llama, index context window, corpus dir, the directory containing the documents, Llama index context window size ingest, the window size, i.e. the number of sentences to include as context, and OpenAI API on key, the API key required for API access. Then loads documents using simple directory reader, raising an exception if no documents are found or an error occurs. It then creates a context window by initializing a sentence window node parser, configured with the window size and metadata keys, using, for example, window to store the enriched text and original sentence to store the original fragment, and sets up an ingestion pipeline with this parser to transform the documents into context-enriched nodes. Following this, the code checks for an existing index by verifying the presence of a file such as docstore.json. If the index exists, the storage context is loaded and the new nodes are inserted, otherwise a new index is created using vector store index. And finally, the updated index is persisted to disk, and the function returns a dictionary containing a success message and the number of documents processed. In Part 2, retrieve.py, the file handles document retrieval from the index and defines a custom post processor to reconstruct the context of extracted nodes, where the custom metadata replacement post processor RR class extends metadata replacement post processor and implements a process method that retrieves the complete text along with context metadata, specifically the window key and original sentence. Searches for the original sentence within the enriched text if the window metadata is present, calculates a character interval around the original sentence based on the value of LLAM, A index context, window max adjacent chars RAG retrieve, and if the original sentence is not found, returns the full window text, thereby producing a trimmed text fragment that provides additional context. The retrieve chart documents function prepares the index and query parameters by reading environment variables such as LLAMA, index context window top, KRAG retrieve to define the number of top results, and LLAMA index context window DB path to locate the index, loads the storage context and index from persistent storage, configures a list of post processors, including the custom metadata replacement post processor, and if a similarity cutoff is provided, a similarity post processor executes the query through a query engine configured with these post processors to obtain source nodes, and for each retrieved node processes the text, whether directly or within a node object, with the custom post processor, so that the final result is a list of strings containing context-enriched text. In conclusion, this technique combines two essential phases: ingestion and enrichment, ensuring that during ingestion, each document is split into chunks and enriched with surrounding sentences to provide a more complete meaning when retrieved, and retrieval and post-processing, where at query time a custom post-processor reconstructs the original text by adding further context based on the position of the original sentence, thereby enhancing result coherence and overcoming the issue of isolated text fragments while delivering more complete and comprehensible responses. Thank you for watching. We hope this deep dive into AutoCodeAgent's advanced capabilities has inspired you to unlock the full potential of AI-driven automation. Stay innovative and see you in the next video.